Hello students, and welcome to another chapter about atoms, molecules, and ions. This is Dalton's atomic theory, in which he stated the following. All matter is made of atoms. So atoms are the building block for all matter. Elements contain identical atoms. So what does that mean? It means that gold atoms are all identical. Silver atoms are all identical, but they are different from the gold atom and so on. Also, atoms combine in a whole number ratio to form compounds. So, for example, if you look at the picture that we have here, you will see that this is here the molecule of water. Every molecule of water has the red sphere, which is the oxygen atom, and two white spheres, which are the two hydrogen atoms. That is a ratio that is fixed for that compound. Chemical reactions only involve the rearrangement of atoms. Atoms are not created or destroyed. Let's look at this together. If this is the element that is made of the red atom, and there is element Y, which is made of the green atoms. Now they react with each other to give me a new molecule, and that molecule is still made of the red atoms and the green atoms. So it's not like I created something that wasn't there. So atoms are not created, nor they are destroyed. It's not like something also happened for this original reactant to disappear. So atoms cannot be created nor destroyed. If I have 16X, which is 16 atoms of element X, plus 8 atoms of element Y, I'm going to get 8 molecules X2Y. So that's what we call the law of conservation of mass. Mass is not created nor destroyed. It just can combine in a certain ratio to form a new compound. The structure of the atom was reached by multiple experiments by different scientists. The cathode ray tube was the experiment that led to the discovery of the electron. As we have noticed that there is a negatively charged particle that was attracted to the positive part of the field, the electrical field that was applied. That scientist that discovered the electron, his name is J.J. Thomson, and what he was able to measure is the mass over charge ratio of the electron. So if this is a question that I will ask you, what was the discovery or the measurement achieved by J.J. Thomson? Make sure that you understand that he was not able to measure the mass nor the charge individually. What he was able to do is to measure the mass over charge ratio of the electron. Let's look at Millikan experiment. What he was able to measure is the charge of the electron. Now remember, Thomson before him had the ratio of the charge over the mass over charge. So since I have this ratio, and now I have the charge measured by the Millikan experiment, then he was also able to calculate, not measure, because that came from calculation, the mass of electron, or of course was awarded a Nobel Prize for such a discovery. Now we know that the charge of the electron is negative 1.60 times 10 to the negative 19 coulomb, and Thomson charge over mass ratio of the electron was negative 1.76 times 10 to the power 8 coulomb per gram. So the calculation that came out is the mass of the electron that was measured at 9.1 times 10 to the negative 28 gram. There are also, at the time, we were aware that there are 3 types of radiation. There were an era where scientists were really obsessed about studying radiation. There is a beta ray, and if you look at this picture, how you see how beta ray was attracted to the positive part of the field here, which means that the conclusion beta ray has a negative charge. Gamma ray went straight forward, which means no charge. And alpha ray, which what we will focus on, was attracted coming down to the negative part of the electrical or the negatively charged electrical plate, which means that alpha ray had a positive charge. Now, at the time when all of this was happening, Thomson came up with a model of an atom, and in his model, he envisioned it to be the atom is a sphere, and electrons are embedded randomly on the spheres. Like, think of it like a raisin muffin. So the electrons are the raisin, and the positive charge is spread over the entire sphere. Right? So like the positive charge pretty much is the cake in the raisin muffin. Till Rutherford and his student were performing an experiment, and what they discovered, we call this the thin gold foil experiment. They were looking and studying the emission of alpha particles. Now remember, we did talk about alpha has a positive charge. And while they were doing their observation, here is what they found out that made them stop and rethink Thomson model of the atom. So what they found and concluded that they found that, I'm going to show you here, that most of the alpha ray went through straightforward. So when they were going through that gold foil, most of them went through in a straight line. However, some of them were deflected, like they came close and deflected, straight and then deflected. And what was even more amazing, that some of them did bounce back. So what they concluded, that Thomson model of the atom cannot be true, because if the positive charge is diluted all over the sphere, then there is no way that there is a bounce back of an alpha particle. Remember, it's positively charged. So what they concluded, that there should be a mass in the middle that does have a positive charge. Most of alpha ray went straight forward because most of that sphere is empty. So alpha ray can go straight forward. Some alpha ray were deflected, and the reason for that is because it came, remember how alpha is positively charged. It came close to the positive charge in the middle, so positive will repel positive and got deflected. And the one that was bouncing back, they concluded that must be that alpha hit that mass that has a positive charge and bounced back accordingly. So their conclusion led to the discovery that there is a mass in the middle, which we call a nucleus right now, and they concluded that most of the atom is empty. The positive charge is concentrated in that nucleus, and that led to the discovery of the particles that we call protons now. Also, mass of the proton was most of like that. The nucleus also has most of the mass, and the mass of the proton is almost 1840 times the mass of electron, which in another word, way heavier than electrons. So that's why most of the mass of the atom is located in the nucleus. Now, Chadwick also discovered neutrons, and his discovery came from the following simple experiment. We knew at the time that hydrogen has one proton and helium has two protons. So they predicted that if I measure the mass ratio between the helium atom and the hydrogen atom, that ratio should be 2 because it's 2/1. However, the measurement showed that helium over hydrogen mass give a ratio of 4, which means helium is 4 times heavier than hydrogen. The only way we can justify that at the time, knowing that helium has only 2 protons, that there must be other particle in the nucleus that has significant mass and contributes to the overall mass of the atom. So, and that particle is neutral, has no charge. That's why we called it a neutron, and it has almost equivalent mass to the proton. So now to summarize, the atom has 3 types of subatomic particles: protons positively charged, neutrons neutral, electrons negatively charged. You can see that the mass, the atomic mass unit used here to express the mass of proton and neutron, and you can see that the mass of a neutron is slightly heavier than the mass of the proton, and then the electron, as we said, is almost 1840 times lighter than both. Atoms are also neutral because there is equal number of protons to electrons. And that does conclude our lecture about the atomic structure. I will see you in the next lecture about the periodic table and isotopes.